In this video we have another system of equations involving log expressions, ln in the first one and the log to base 3 in the second one. And we can use any method. So let's try to eliminate the natural log and just come up with an expression involving just the x and the y. So the first one, we write this as natural log of x. And then I'm going to use the property of logs that allows me to take this exponent or this coefficient here into an exponent. So this will come over here as an exponent. And this would be ln of y to the fourth. So now I have a natural log of x equal to the natural log of y to the fourth. Nothing else is added or subtracted. So in this situation, natural log over here of this, and natural log of y to the fourth. The only way these two can be equal is if these are the same. That's another property of your logs. So I can rewrite this as x then can equal to y to the fourth. So the log expression in the first part of the first equation reduces to x equal to y to the fourth. Now in the second one, let's do this. I'm going to take the 2 on the right side, that is this 2 right here to the left, that'll be becomes a negative, and I'll be left on the right side with 2 times the log of y to base 3. Then this will come over, adding the opposite to both sides, so this will be a minus natural log, or I should say the log of x to base 3. So I brought this over to the side, change the sign. The 2 goes over to the left, changes the sign. So I still get minus 2 here. Again, same property, this coefficient can become a exponent here, so this becomes the log of y squared to base 3. And then it's minus the log to base 3 of x. So this is then minus 2 will equal to, anytime we have a difference of logs, as long as the coefficient here is a 1, or in this case it's a 1 also, got the minus. The difference that 2 logs are the same base can be written as the log of this component over this one, or y squared over x. Going the other way, the log of a fraction will equal to the log of the numerator over the minus the log of the denominator. So we're going the opposite way here. This difference can be written this way. And then I'm going to apply the property of logs. Anytime you have the log of some expression to some base equal to a number, whatever the expression or number is, in this case y squared over x, will equal to the base here, which is 3, to the negative 2. We're just going from the logarithmic form to the exponential form. So y squared over x then will equal to 3 to the negative 2. So this will be the same thing as y squared over x equal to, and then 3 to the negative 2 is just 1 over 9, 1 over 3 squared. So we're in this way. And this is cross multiply here, this will be 9 y squared equal to x. So then I got this equation, 9 y squared equal to x. Now I have a system, but I don't have any logs involved, just regular x and y components here. So I can solve it by substitution. This tells me, the first one tells me that x is equal to y to the fourth. I have an x right here, that's the easiest substitution then. So I have a 9 y squared equal to, and then making the substitution for x equal y to the fourth. So we got this. Bring that over to the other side. So this will be 0 over here. And I have y to the fourth minus 9y squared. So I got a fourth degree equation to solve. So let's factor out a y squared here. Y squared, I'm left with y squared minus 9. So this will be y squared. And let's factor this out. Difference of squares, so y squared minus 9 can be factored into y minus 3 and y plus 3. So I got factors, product of factors equal to 0. That means 1 or every factor is equal to 0. So we just said each factor equal to 0. So y squared equal to 0. The only value that will satisfy that equation is y equal to 0. Y would equal to 0 here. But okay, look at your equation. Anytime you have a log, the number you take the log of has to be positive. Cannot be negative or 0. So here I have the log of y over here. Log of y to base 3. So this one I have to reject. This won't work. The next one then, y minus 3 can be 0. And the only way that can happen is if y is equal to 3. We can't take the log of 3, so that's not a problem. So this would be a prospective solution. So we need to check it. And the next one we have is y plus 3 can be 0. Which means if I solve that, y has to be a negative 3. But again, here on this one here I have the natural log of y. Y is negative 3. This one again can't work. This is out. Throw that away. So the only possible solution that we can have to start off with is that y can be 3. Remember, we're looking for y and x. So we go back to this one right here. Possible solution then, I'll put it as an ordered pair. So y is a possibility. That could be 3. Over here in the first equation, 3 to the 4th is 81. I could use either equation. I put a 3 here. 3 squared is 9. 9 times 9 is 81. So either way. But this is what we get as a possible solution. 81 and 3. So let's check it here. In the first one, oh, and again, you always go back to the original equation to check. Even though I could check it here. I could check it right here, but always go back to the original equation. Because depending on the type of equations you're working, it might work over here, but it won't work for the original one. So always go, when you do a check, always go to the original equation. So if we try to check for the first one, x is 81, so this will be the natural log of 81, and this will be, on the right side, I'd have 4 natural log of 3. So natural log of 81, does that equal to 4 times the natural log of 3? Yes, because this is the same thing as bringing this over here. So I bring this power over here. 3 to the 4th is 81, so I get natural log of 81 equals natural log of 81. So that does check. Again, there's some equations where it might work for it might check in the first equation, but not in the second or third, depending on how many equations you have in the system. So you got to go to the other one. So for the second equation, check it out. It's the log of x, and x is 81. So log of 81 to base 3 has to equal the 2 plus 2, the log of y to base 3. So let's see if this checks. The log of 81 to base 3 is equal to 4. So this is 4. Because 3 to the 4th is 81. That's your definition log. Okay, does that equal to 2 plus 2? And then this right here, the log of 3 to base 3 is 1, because 3 to the first power, 3 to the 1 power is 3. So this is 1 times 2 is 2. So this is 4. So there's your check. So the solution set then is the ordered pair, 81 and 3. So x equal 81, y equal 3, or let's say solution pair. We write it like this. Thanks for watching. We'll see you next time.